next case, you've been told to use Simpson's rule with 6 interval to evaluate that integral, isn't it? So in Simpson's rule, it's just an extension of the trapezoidal rule, isn't it? And one thing we show is that the number of strips was the same as here it was the same as the number of intervals, because each interval for each strip. So when there are 6 intervals, meaning there are 6 strips, isn't it? So how many ordinates are those? 6 intervals in Simpson's rule. How many ordinates? Ordinates are always more, isn't it?
Yes.
It's only in mid-ordinate rule where ordinates are the same as strips, isn't it? Ordinates are always more because the ordinates are in both ends, isn't it? So ordinates in 6 intervals means how many ordinates? 7? 7 ordinates, isn't it? Then you list those ordinates from Y node. So it is Y node, Y1, Y2, Y3, Y4, Y5, then Y6 is the 7th one because we started with Y node, isn't it? After you've listed all the ordinates you are going to use, the next thing to get is H, the size of each interval, isn't it?
Yes.
So H, you know, it is starting from 0.2 and moving up to 0.8, meaning the whole of that range is 0.8 minus 0.4, isn't it? Yes. And that range of 0.8 minus 0.2, it is divided into how many equal intervals?
6.
It is divided into 6 equal intervals, isn't it? Are we together? Yes. So what do you get to be the H, the size of each interval? 0.6 divided by 6 is 0.1. After getting H, you get the starting point, X node, isn't it? So in Simpson's rule and trapezoidal rule, the starting point is exactly that point where it starts, isn't it? Yes. Only mid-ordinate rule is where it is in the middle of the first interval. You look for it, isn't it? So our starting point is 0.2. Very different with the mid-ordinate rule. Are we together? So after we found that, the next thing is to get the function y, isn't it? What is y? You know when you are getting the area, you are integrating f of xd. And if y is the function of x, then where there is f of x, you put y. So it's like you are integrating y dx. So if you move this your dx, whatever is remaining there is the y, isn't it? So if you remove the x, y is going to be what? X over square root of 1 plus x cubed. You found the y. Are we together? Then after that, before we even record the formula, we can start by forming the table. Then we record the formula of Simpson's rule, isn't it? Or we start with the formula, then we form the table, isn't it? So what is the formula of getting the area? According to Simpson's rule, it is the extension of the trapezoidal rule. In mid-ordinate, it was starting with edge, trapezoidal, a half edge. Simpson's, it was a third edge. Then sum of the ends. What are the ends? Y naught and?
Y6.
Y naught and Y6. Then twice the avos, isn't it? So the avos are Y2 and Y2 plus Y4. Then plus 4 times the remaining odds, isn't it? Which ones are the remaining odds? Y1, Y3 and Y5. Are we together?
Yes.
Y1 plus Y3 plus Y5. So that is the reason why we are starting with the Y node, so that we can easily master the formula. 2 times 2 is 4, 4 times 1 is 4, 4 and 4 balance. That is a means of mastering the formula. Only if you start with Y node, isn't it?
Yes.
Are we together?
Yes.
Okay?
Yes.
Very good. So once we've written the formula of getting the error by Simpson's, we form our table with the values, isn't it?
Yes.
So our table, we have how many ordinates? 7 ordinates. So we have 7 rows, isn't it? So form a table with 7 rows. 1, the second row, third row, fourth row, fifth row, sixth row, seventh row. Then you divide. So we start our edge. We found is 0 point. Our edge was 0.1, isn't it? Then our x naught, the starting point. X naught is 0.2.
Yes.
Our x naught is 0.2. So what is x1? X naught plus h gives you x1, isn't it? X1 is 0. Then x2 x1 plus h gives you x2, which is 0 point. Then x3, x2 plus h gives you x3, which is 0 point. Are we together? Then x4, x3 plus h gives you x4, which is 0 point. 6. Then x5, x4 plus h gives you x5, which is 0 point. 7, isn't it? Then x6, x5 plus h gives you x6, which is 0 point. 8. So you see you would have reached the end, 0.8, isn't it? We get the corresponding y. x0 gives you y0, x1 gives you y1, x2 gives you y2, x3 gives you y3, x4 gives you y4, x5 gives you y5, x6 gives you y. Are we together?
Yes.
So use your formula for y. Y, then you can see it is x over square root of 1 plus x cubed. So when you're looking for y naught, if you put naught where there is y, you put naught where there is x, isn't it? So y naught will be x naught over, and what is your x naught? 0.2 over square root of 1 plus x naught, which is 0.2 cubed. So what is y naught? If you are not all the number of decimal places, 4 decimal places is very convenient. You get to be 0.1992. Then after that, are we together?
Yes.
After that we move to, so you will see those same values are the same values you got in trapezoidal, the way they are, isn't it? Yes. Then when you move there, you use that. When you are now looking for y1, you put 1 where there is x in it. So y1 will be x1, which is 0.3, then square root of 1 plus 0.3 cubed. You substitute the value of x1, isn't it? You get y1 to be 0.296. So if you are looking for y2, when you put 2 here, you put 2 in x. So it will be x2, which is 0.4 over square root of 1 plus 0.4 cubed. You get y2 to be 0.3878, isn't it?
Yes.
Like that, you do again for y3. If you put 3 here, you put 3 for x. Will be x3, which is 0.5 over square root of 1 plus 0.5 cubed. What do you get?
0.471.
47114. Then you move to, when there is y4, you put x4 there, isn't it? So x4 will be 0.6 over square root of 1 plus 0.6 cubed. What do you have?
0.5441.
0.5441. Then y5 continue with the same procedure. What do you get to be y5?
0.64.
0.6460.
Yes.
4.
0.
Then what do you find to be y6? If you put 6 there, x6, x6, x0, 0.8, 0.8. You have?
0.6506.
650. So you found everything. We are done there, isn't it? So the next thing is to substitute them in the formula to get the area, isn't it? So what is the area? It is a half edge. A third edge, good. It is a third edge, then a third edge, then you move. Y0 plus y6, go to the calculator. Y0 plus y6, you have 0.8498. Then it is plus 2y is y2 plus y4. So 2 in bracket y2 plus y4. What is the calculator giving you? 2 then inside the bracket you put your y2 plus y4. You have? What do you get? y2 plus y4, then you multiply by the answer by 2. What do we have to be this part?
1.8638.
1.838. Then y1 plus y3 plus y5, y1 plus y3 plus y5. What do you get? Then you multiply it by 4, the answer by 4. y1 plus y3 plus y5, then answer times 4. What do you get if you multiply the answer by 4? This is 8. y1 y1 plus y3 plus y5. What have you found? 5.56. That is 10. So can you add everything inside the bracket? 0.8498 plus 1.8638 plus 5.4856. What do you get to be the whole answer inside the bracket? What do you get? The whole answer inside the bracket you have?
8.1992.
8.1992. So a third times that 8.192. So if you now multiply the 3, what do you get? Answer times a third times 0.1. What do you get to be the final answer there? You have 0.273. 33. 0.2733 into 4 decimal places, isn't it? So you can see the area with the melodic rule was approximately the area with the trapezoidal rule, and we've confirmed now the same with the Simpson's rule. There's a very infinitesimal error in approximation. It is the actual integration which will give the actual area, isn't it? Are we together? Good. So that is how to deal with the Simpson's rule. That is how to deal with the Simpson's rule.